The best thing in the world about factorials is that they make fractions behave themselves. Check it out, guys. Let's say you're asked to figure out, I don't know, 6 factorial over 4 factorial. Well, that might start to look like a nightmare. So on top we've got 6 times 5 times 4 times 3 times 2 times 1. And on the bottom we've got 4 times 3 times 2 times 1. And if you don't think about it too hard, you might try to multiply all the numbers together before you divide. But dudes, don't do that. Check it out. We can just cancel most of the numbers on top and on bottom. So much cancels that the only thing that we're left with is a 6 and a 5 on top, and we've canceled everything on bottom, and so when you do that, the thing that's left over is a 1. 6 times 5 on top divided by 1, that's just a 30, dudes. And that's how you do factorials and fractions. Now, one last tip. Sometimes you're going to see problems that use the variable n instead of actually giving you numbers. And that can feel a bit confusing, but it works the exact same way. So here's an example. If you have n plus 1 factorial on top and n minus 1 factorial on bottom, then you can write the top as, well, remember how we do factorials. We start with the number they give us, and then we multiply until we get down to 1. So it's going to look like n plus 1 times n itself times n minus 1 all the way down to 1. On bottom, it's going to be the same thing. We're going to start with the number they give us, which is n minus 1, and then we multiply n minus 2, n minus 3, all the way down until we get to 1. And the same pattern happens, dudes. Everything on bottom is going to cancel out with something on top, and all we're going to be left with is the n plus 1 and the n on its own left from the top. So we have n plus 1 times n, and you multiply those bad boys together, and you have this expression right here. That's it for factorials, dudes.